Hey math kids, today we're going to talk about rational functions. And all a rational function is if we have a function over a function. So we could have two quadratics on top of each other. And if we write it like that, it's just called a rational function. So let's just get started. So y equals 6 over x minus 2, and then plus 4. So we're asked to find the asymptotes of the function, the axis intercepts, and then use technology to help sketch the function based on that. So asymptotes are going to be wherever either x or y cannot equal 0. And so right here, x cannot equal 2 because that would create division by 0. And so we have a vertical asymptote at x equals 2. Now, to find the y asymptote, or sorry, the horizontal asymptote, which is dependent on y, we solve for x. And so y minus 4 equals 6 over x minus 2. And we want x on top, so we flip both sides of the equation. And then we multiply by 6. And then we add 2. Now, there's probably a point where you can see where the asymptote would be. Once it's really like right here, we can tell what the asymptote is. But, I don't know, for completion's sake, I guess, I like taking it out this far. But right here, we can see that y cannot equal 4. So y cannot equal 4. So that gives us a horizontal asymptote at y equals 4. Okay, so that answered part A. Part A just wanted the asymptotes. Now we want to find the axis intercepts. And so to do that, we just plug in 0 for each of x or y. So in the orange function right here, not this one. Here, I'll just get that off the screen. We don't need that. So the orange function right here, if we plug in 0 for x and simplify it, that will give us a y-intercept. In this yellow function down here, if we plug in 0 for y, that will give us our x-intercept. So that's another reason why taking this all the way to the end is useful. Okay, so I'm going to plug in 0 for x right here, and that's going to give me y equals 6 over negative 2 plus 4. And so 6 over negative 2, that's going to be negative 3 plus 4, and so y is equal to 1. And so we have a y-intercept at y equals 1. Okay, now if I use the yellow one and plug in a 0 for y, I get 6 over negative 4 plus 2 equals x. And so that's going to be negative 3 halves plus 2. And so 2, if I get a common denominator, would be 4 halves. And so x equals 1 half. So we get an x-intercept at x equals 1 half. Okay, now we have all of this information that can help us graph it a little more precisely. Now if we just go to our calculator, let's see, no, calculator, and we graph this. So we do 6 divided by x minus 2, and then plus 4. So we want to graph this. Let's see. Put this over here. Now, when we're sketching this, we look at our vertical asymptote. And so x equals 2, that's pretty good. That looks like a vertical asymptote right there. Then y equals 4, 1, 2, 3, 4. Y equals 4, okay, that matches up. And then we have a y-intercept at 1, that looks true. And then we have an x-intercept at 1/2, that also looks true. So when we're trying to sketch this, we're going to do our axis intercept, or draw our axes, and then at x equals 2, and then y equals 4, draw those asymptotes. And then we're going to cross at 1 on the y-axis and 1/2 on the x. So we get something that looks like that, and then something that looks like that. And you can see it's not perfect, but it looks pretty close to what was on the graphing calculator. Okay, now they're just asking us to draw a sign diagram for this rational expression. Okay, so we want to know where this goes to 0, like where this would cross the x-axis, right? And so you actually just use the top. So what would set the top equal to 0? Well, x equals 1 is where that's going to happen. And then we use the bottom. We set the bottom equal to 0 to tell us about any asymptotes. So we subtract 1, 2x equals -1 divided by 2, x equals -1/2. And that's going to be a vertical asymptote. And so the way that this shows up on a sign diagram is we have 1, which is a root, and then we have -1/2, which is a asymptote. So you just kind of draw it like that. Okay, so we need to figure out where it's positive, where it's negative, and so we're just going to choose numbers that fall into these different places. So we want to know a number in between -1/2 and 1. 0 is probably the best choice. And then 2 would be greater than 1, and then -1 would be less than -1/2. And then we're going to just plug it into this thing, the original, and see what we get. So if I plug in a -1 on top, it's going to be negative minus a negative, so the top is going to be negative. Now if I plug in a -1 right here, I'm going to get -2 plus 1, which is also a negative. And so negative divided by a negative gives me a positive. Okay, now if I plug in 0, I get a negative on top. If I plug in a 0 here, I get a positive on bottom. Negative divided by positive gives me a negative. And the last one, if I plug in a 2, if I plug in a 2 on top, I get +1. If I plug in a 2 here, it's going to be positive plus positive, and then positive divided by positive gives me a positive. And so that would be my sign diagram, and that's all they ask for. Okay, we just have one more example, and then we'll be done. It's pretty involved though, so this will take us a little while. Okay, so they give us this function. Okay, and it says find the vertical asymptote of this function, and then find the axis intercepts. Okay, so they just tell us there's only a vertical one, so we only need to find that one. So division by 0 happens when x equals 1. So we have a vertical asymptote at x equals 1. Once again, it's just whatever creates division by 0. Okay, now to find the axis intercepts, we have to plug in 0 for the x's. So 2 times 0 plus 1, 0 minus 1. So that's going to be 1 over negative 1. And so we have a y-intercept at negative 1. Okay. Now to find the x-intercepts, we actually only have to worry about the top. Now the reason why we only worry about the top, I'm just going to show you this. 2x plus 1 over x minus 1. The first step in this algebra would be to multiply both sides by x minus 1. So that cancels this, but x minus 1 times 0 is still 0. And so there is a shortcut where we can just set the top equal to 0 and be done. So we minus 1, negative 1 equals 2x, divide by 2, divide by 2. And so we have an x-intercept at negative 1/2. Okay, and now C says rearrange the function to find the horizontal asymptote. Okay, so I guess they do want us to do that. So I'm going to think of this just like a y. Okay, now so to do this, it's pretty involved. It's a little tricky. So we want to solve for x, so let's see if we can do it. So we multiply both sides. Now I'm going to distribute. So we have yx minus y equals 2x plus 1. Now I'm going to get all the x's onto one side. So I'm going to subtract 2x while also adding y to get this onto this side. So I have yx minus 2x equals y plus 1. Now I'll factor out an x. And then divide. And so x equals y plus 1 over y minus 2. And so the horizontal asymptote will be where y creates division by 0, so that's at 2. And so horizontal asymptote at y equals 2. Okay, draw a sign diagram of the function. So go back to the original function, written in pink right here. And for our sign diagram, we just need to know our x-axis stuff. And so we have a x-intercept, and then we also have an asymptote. Okay, so we just want to pick those values. So 0 would fall there, 2 would fall there, negative 1 would fall into that zone. Okay, so if I'm going to do the negative 1 first. So if I plug in a negative 1 here, it's going to be negative 2 plus 1, which is a negative answer. And if I do a negative 1 here, negative, negative, negative minus a number is going to be negative still. And so negative times negative, or negative divided by negative, will give me a positive. Now if I plug in 0, I end up with a positive 1. If I plug in 0, I end up with a negative 1. And so positive divided by negative is going to give me a negative. And then the last thing, plug in a 2. That's going to give me positive on top. And then if I plug in a 2, positive on bottom. And so positive divided by positive will give me positive. So there's my sign diagram. And then we got 2 more parts still. It says, hence discuss the behavior of the function near the asymptotes. All right. So what that means, we're going to write it like, what is that word called, or that phrase? End behavior, in a sense. So this is notation I think is new to you. I can't remember if we've talked about this notation yet. But we're going to say things like, as x approaches 1 from the negative side, what does y do? Well, f of x approaches negative infinity. So what that means, if we approach 1, so we're going to this asymptote, then from this side, then we're going to go down on the y-axis. Here, I'm going to show you like with a graph. I think this is too hard to explain without a graph. So 2x plus 1 divided by x minus 1. Okay, so we have this vertical asymptote right here at 1. And as we approach, meaning we go towards it from the left side or the negative side, then we're going to go down as far as y values are concerned. And so that's what this means. As we approach 1 from the negative side, our y values approach negative infinity. Okay, now if we approach it from the other side, what do our y values do? So now if we come from this side, the positive side, if we approach, our y values start to increase. And so that's going to be positive infinity. Okay, now we're going to do the horizontal asymptote. Now the way I like to think of when we're doing horizontal, I start with my y value actually, even though the notation doesn't start with the y value. So we're going to approach 2, which is our horizontal asymptote, from the negative side. So if we're approaching 2 from the negative side, our x values go towards negative infinity. So we're going to say x approaches negative infinity. Okay, now if our y values approach 2 from the positive side, what does our x do? So if we're on the positive side and we start to approach this horizontal asymptote, it was going like this, and so our x values approach positive infinity. So go back and look at the graph on the video if that confused you, but as we go towards it, if we start on the positive side and go down towards that asymptote, the x values, we're going to go to positive infinity. And so that's how I got this thing. Okay, now sketch the function showing the features you have found. All right. Okay, so we have vertical asymptote at 1. We have a horizontal asymptote at 2. And we have an X-intercept at -1/2. And we have a Y-intercept at -1. And so as we approach we go down. Okay, so that makes sense. So it's going to look like that. And then it's going to look like that, kind of. All right, there's our function. If you have additional questions, please come to Math Lab. Until then, calculator.